Yeah, over to you.
Hey guys. So the graveyard shift. I'd like to think you've all been waiting for the exciting grand finale. So hopefully we don't let you down. So my name's DBS. I work for Mesh AI. We are a startup 2 years old this week. We've got about 100 people working in largely regulated organizations, and our main focus is in energy and utilities and financial services. And our role is to transform how they use data to actually do AI. And I've got some great panelists here today. I'm going to be poking them with some challenging questions and hopefully be interesting to you all. So if you want to introduce yourselves, and then we'll get to the questions.
Thank you. My name is Tarja Strahlman. I work for quite a similar company, Faculty AI, a little bit older. We're about 10 years in, 300 people. I myself am pretty new. Applied AI, as well as some productization going on, but primarily services and finding solutions for various problems across industries that can be solved with AI techniques. We're split between 4 business units roughly, so we do quite a lot of work with the government, healthcare, life sciences. The COVID early warning system was us. We do a lot of work with the NHS. Retail and consumer, and then energy transition, which is the practice that I'm in. We're the youngest one, about 2 years in. And my background is in energy. So again, forgive the bias in terms of net zero and climate. I think energy underpins it all. I spent a long time in Shell before this, so that's kind of the angle that I probably bring into the conversation.
Good evening, everybody. My name is Henry Franks. I'm Chief Technology Officer with Climate Policy Radar. We are 2023's Buzzword Bingo champions. We're a non-profit, open source climate tech AI startup. And so what we really look at is climate law and policy globally as one of the main levers that we can pull for effective climate-aligned action across the world, and opening up the sort of black box of vast libraries of unstructured data and documentation that represents, so primarily NLP focused, as well as the modern hyped up generative AI, large language models things, but what we also term more traditional nowadays, at least 2 years old techniques for helping people get insight out of these documents. And to give you an example of the scale of this, we currently have every single global climate national level law or policy. That represents 230,000 pages of documentation. The submissions to the global stocktake this year, which we were talking about earlier, totaled 170,000 pages of documentation. And obviously the analysis of that is a rather tricky challenge to solve, and we've taken it upon ourselves to try that.
Hello, everyone. Good afternoon. I'm Simon Bennett. I'm Head of Research and Innovation at AVEVA. That's AVEVA with an E, not an I. I'm not in insurance. Sorry, it's become the standard mantra for anyone who works in the company. We're a software company, UK headquartered, around 6,500 employees. We have global business and product solutions in the software domain for most of the world's industries. So we supply software to heavy industries such as shipbuilding, to the power industry, to pharmaceuticals, to chemicals, to the process industries, mining, all of the, what you'd probably call, most impactful businesses in the world from a climate point of view. But the good news is they're extremely rich data environments that often operate in those organizations, which means that there's a good intersection for where AI might be able to help them to improve their sustainability outlooks.
Okay, so we've heard a lot about the challenges ahead of us today, and I think we all know that we have to move the needle. To accompany that, as mentioned, we also are aware of the hype of AI since probably last November, Mr. ChatGPT. I have a lot to thank ChatGPT for, but I think these guys will agree it causes us a lot of pain. I was going to ask actually how many people know what NLP is versus Gen AI. which is an interesting question. But my first question to all of you, can you make the case for AI? How can it be used to tackle net zero? And I'll start with you, Tarja.
Sure. Thank you. I'm going to start quite high level, and again, being quite new to tech, frankly, myself, small admission, is we talk a lot about this comparison between digitalization and the transition that's happened in the last few decades. And, if you'd asked 10 years ago, you wouldn't necessarily believe that every company is going to be tech-first company. And now it really is the case. So you don't have filing cabinets, you've got servers somewhere. Your shop front is probably a website now, stuff like that. And I think the kind of AI transition is a very similarly profound change, except it's happening way faster. And probably going to be more profound, actually, the most important technology in many generations. And I think part of the reason it's going to be faster is that, well, you're building on infrastructure and data that's being collected because, you've been able to digitize many processes across industries. But I think what will be different, or certainly, where we like to try and play a part, is not sort of, pick apps or have a, I don't know, your ChatGPT interface type of thing, but really think about how can you reimagine business processes by using AI. So go into the kind of heart of what's the problem that you're really trying to solve. What actions does it drive? Do you understand the causalities, cause and effect relationships between stuff that happens within your business? And then start thinking about, well, what's the data that I need? Do I have it? Is it in the right format? So don't start with, okay, let's spend 2 years building our data fabric and then figure out what dashboard to build on top. So that's sort of, decision loop, we call it, to understand what are you trying to get to before you even start thinking about like what machine learning models you might need. So long story short, I think it's irrelevant whether you're talking about net zero or decarbonization or energy. AI is touching every single industry. And in, like I said, energy is sort of the angle that I'm coming at because, we're moving into an increasingly electrified economy, whichever way you look at it, meaning you're less dependent on fossil fuels. That generation should really move into, and it's moving into renewables. And what that means is increased complexity in terms of the energy system. So you don't have like a baseline of gas turbines or nuclear power plants running, much more intermittent generation, different demand patterns, different utilization patterns, which is really ripe for those kinds of like real-time optimization where AI performs really well. So that is kind of, I guess, the killer use case or theme where I believe that AI can play a really significant role in getting us to a much more decarbonized world at the end of the day.
I definitely want to echo absolutely all of that. That was really hit the mark for me. We have a sort of informal mantra at CPR, Climate Policy Radar, of good data doesn't necessarily entail good decisions, but bad data guarantees bad decisions. And ultimately, with the scale of data that is being generated and processed and is sitting there in silos and locked basements of data centers and all of this sort of thing, often the result is not going for the bad data, but just going for no data. It's going to take too long for us to try and work out how to interpret this or parse this or get the insight out of it that we need. And no data also guarantees bad decisions. And for us to really move the needle on the climate crisis, we need to make good decisions. We need to make climate-aligned decisions globally at every levels of society. So for me, AI is a force multiplier. If you can 10x or 100x the capabilities and the qualities of everyone, knowledge workers and processes, systems that around the world, then we can start to approach the scale of the problem. We've heard a lot about the scale of the crisis. It is fundamentally a problem of scale, and that's why there's no silver bullets, because there needs to be a huge scale of response back. And in many ways, AI has hit a critical mass, I think, in terms of diffusion and capability in being able to help us scale our response to it, because anywhere there is good decisions that can be made based on intelligent understanding of data, of patterns in data, of correlations, not necessarily causations, because machine learning's not so good at that yet, but correlations certainly, then these are areas where AI can really be applied. In my domain, we're specifically looking at like knowledge workers and who have to answer complex research questions, sort of what are the different ways that renewables are being subsidized across the global south. That is a question that at the moment might take a team of 3 to 6 analysts 3 to 6 months to compile a report on, which is absolutely unacceptably slow. 90 to 95% of that process is going to be inessential complexity, finding the documents, reading the documents. We just ingested one of the UNFCCC documents last week into our database that was 1,500 pages long. And you can't expect anyone to be able to make good decisions off of the back of that. So the way we try to frame this is as augmented intelligence rather than artificial intelligence, augmenting and empowering people to be able to focus on their core competencies. I'm a policy analyst, and I want to make a decision about the best policy that intervention that can be made here. You're not being paid to sit and search through different government websites, to sit and sift through 1,500 pages of documents. You're being paid for your expertise. And AI as a force multiplier allows you to get rid of that 90 to 95% of those processes that are inessential complexities and focus on the bits that really work well.
Okay, so I'm going to give a couple of examples of where I've seen it in the industrial sector being taken advantage of. So the business case itself is not something that we make as a software company. It's definitely something our customers make. They need to understand the problem they're trying to solve from a sustainability angle, and then they can describe that problem to us. And it has to start with a problem discussion. We can't just say, we've got some great tech, have it off the shelf, and it'll solve your problem. You have to understand what the problem is. But there are 4 examples I've got of customers who've really moved forward in certain areas. So if you're designing a process plant or anything like a chemical plant, the first thing you do is you take industrial chemists and they use mathematics and first principle science to do simulation model of that chemical process. Nearly always, the outcome is targeted on the most profitable process, and it has been for decades. What is the most profitable process to do this chemistry? We're using grey box simulation, which is an AI augmentation of first principle science, to be able to offer them a new target, which is lowest carbon emission for that particular, and then balance that with a profitability. So we're putting them right in the front of their face, profitability and sustainability, and then offer them the choice of where they want to sit on their level of ethical citizenship. So that's one area. One area as well is that we have 3D software, so 3D CAD software. So there's somebody sitting somewhere at the minute who is designing a plant, whether that be a manufacturing building or some kind of huge infrastructure. And they're using a 3D tool, and they're again basing their design decisions, should I use this much steel or this much concrete, or should it be 3 meters high or 4 meters high, based around profitability and the procedures of that particular business. We want to intervene in that design process and give that engineer an in-the-moment assessment of what the sustainability impact is of that design. So we're using generative AI to help them to see future outcomes with this design ethic that they're choosing, which I think is a really challenging environment for our customer. Another one is predictive analytics. So when they've actually got the asset and it's running, whether that be a factory making Weetabix or BMWs or whatever it is, that they have a huge amount of sensor data coming from all of their machines, and they can use that data, those millisecond pieces of information, look back in history and put predictive analytics tools, AI tools on top of that to project future potential failures. And we have many, many examples over the years of customers who've used that data to understand that a bearing may be at fault, or some machine is vibrating more, or there's higher pressures here, and in the next 3 weeks that needs to be changed oil. So these are small incremental changes, but AI is used to help people to understand how to make more resilient assets, nodding back to the last presentation. And the final one is computer vision, so getting streamed data from videos, thermal imagery, and all of that kind of information to help our customers to understand rogue emissions, and harmful gas exhaust that they have in their process plant or in their assets, and to be able to use that data to predict future potential patterns so that they can mitigate and reduce emissions. And they're just some of the examples where our customers have really come forward.
Yeah, I think that last one brings it to life. You've jumped into my next set of questions about real examples. There's a couple of things that you guys mentioned I just want to pick up on. So, Tarja, you mentioned design around a problem. And I think one of the problems with AI today is that it's kind of seen separately from people and from the way that industries have been built. And you also mentioned about moving fast and moving slow. And we talked about this earlier, this idea of renewable energy is built off of technology. So the richness of data that you have inherent within renewable is vastly different to infrastructure that's been sat for years, hundreds of years even. And how do you bring those two things together, which is a big challenge? I think, Henry, you talked about using AI to get rid of low-value tasks, speed it up, and increase our ability as humans to do high-value tasks. Tell me if I'm on the wrong bit here.
Very well summarised.
And Simon, you gave some really good examples. So I'm going to ask the other two panelists now to give some real examples of projects that can bring to life the impact of AI, specifically in the sectors that you guys are focused on.
Just as a slight tangential one to that, to echo the computer vision one, we've worked with an organisation that uses satellite imagery to pinpoint and quantify emissions globally, which has been a wonderful source of data to correlate with our kind of policy data. The real-world example for me that always really brings it home was a very large institutional investor that we worked with, who were evaluating a portfolio of 10,000 companies for their ESG statements and the extent to which that they were aligned with the policy targets of their registered jurisdictions, which meant that they were control F-ing through roughly 11,000 PDFs. And we are currently building successfully a machine learning model that can pull out that exact information, which makes that work, which was going to be a year's work for a team of 8 analysts, the work of one analyst for all of a week. And I think for me, that's that's one of the most powerful examples I see with this is that's sort of 3 orders of magnitude that you get from the sort of a good application of this sort of thing. Example, but it's completely lost, go out of my brain, so I'll pass it over to you in a moment.
You can tag team, it's okay. Yeah, so in the energy space, I will paint a picture for 1 minute, not assuming that everybody knows the ins and outs of how the grid works, for instance. But generally, the challenge, like I said, is we're moving into an electrified economy. Energy demand is increasing. The role of renewables is increasing, which is great. They are now competitive and cheaper than certainly coal and other fossil sources to an extent. But what that means for the grid and the sort of networks that take the electrons from generation to the consumer is there is much more complexity generally in that system to make sure that the voltage is safe and you're managing supply and demand because you have fluctuation on the generation side as well as on the demand side. So what that means is obviously we're not going to build another grid. We'd need 2 or 3 more in the UK of the network that we currently have in terms of infrastructure. So what you then need is you need to get more innovative in terms of how you manage that flex and that movement on the network. And that means you need to understand, well, what's happening? What is the demand and the supply balance? And how do you then manage the infrastructure, the assets that make all of that happen and keep our lights on? So long story short, I think the specific use cases are, to make it a bit more real, it's the kind of work that we're doing, is take substations. So you have kind of transformers that take the energy from high voltage to low voltage. These are the sort of smaller substations that you see in neighborhoods, thousands of them in the UK. And the way that they manage demand and supply is they will put and fill in gaps where they know they might happen. They put in tenders for a year, 6 months to a year out to flex providers, so industrial assets and things who feel like they can fill gaps where required. But the generators don't necessarily know when they're going to have, that's not the kind of timescale that they plan on. And because the demand at that level, that kind of broken up consumer level, is so not aggregated, it's very difficult to make predictions on top of past data until now. And what that then means is if you are able to predict demand at a very granular level, you are then able to create much more efficient markets and open up opportunities for, whether it's industrial flex assets or kind of aggregated consumer response where suddenly households can go and, you have extra solar or battery storage in your house, so you switch off you do your dishwasher in the night with your smart dishwasher, and suddenly you're then rewarded for taking part in managing that flexibility across the markets. And AI and data is at the heart of that, and that's the kind of work that we're starting to get into with the kind of network operators who manage that very aggregate or that very kind of local level balancing of the networks. So it gets pretty technical pretty quickly, and again, networks is not my background, but very rich areas of kind of optimization in that. And I think the other angle then is your generator picture. Again, your renewable generators who, again, because of that fluctuating pattern of their generation from a wind asset, let's say, we're starting to see increasing sort of requirement for hybrid assets where you might have solar and battery, or wind and hydrogen electrolyzers, various things, in order to get those renewable generators also be able to take part in balancing the grid in different ways. Which also opens up new market opportunities for them, because you're able to participate in the electricity markets in a different way, because you can decide, oh, well, I'm not going to sell today, I'll wait until tomorrow, I'll charge my battery today and discharge tomorrow when the prices are higher, and ultimately prevent curtailment of wind, for instance, which is a real problem now. We actually sometimes have more generation than we need. And again, make the sort of the business case more balanced for the renewable generators as well. And that, again, requires this sort of dynamic optimization of your assets. The kind of industrial area is something very close to my heart. And AI is at the heart of that. So sort of very complicated real-time cases where you can't do that with Excels or physics-based models. So AI is, really required.
I'm going to go off script here and ask a question, which is, I think we've talked about lots of...
Don't do this.
Yeah, sorry. I promised I would. Lots of individual applications which in themselves are quite easy to conceptualize, but in reality, talk about something like the grid, right? You've got a number of these applications of AI and machine learning that are used and have value across different areas of the grid. How do we bring these things together? Right, and we've got questions about challenges of AI, but I think you started to get really close to how we solve for that. And I think, specifically when we move our thinking forwards to the future, I think that's probably one of the issues, is that we look in isolation, and instead of we looked across, and the movement of data, we heard it in the last panel, the movement of data is what creates solutions that are better than the ones that came before. So I'm interested to hear the three of yours viewpoints on how we solve for that in a world that's also moving day by day.
Yeah, I'll have a go at it. What we've experienced is huge heterogeneous data sources. Really, really difficult and hard work, and frankly boring work, to take 50 years worth of operational data and standardize it against the kind of known class library or a data dictionary that defines how your business operates. That's the hard yards that you need to put in to even offer up a platform to do any AI on top of. And I don't think it's the sexy end of the story. We all know that. But the reality is that once you've gone through that hard work, you have a true appreciation of what the value of your data is in your business, and then you can really flex some of those advantages. But I think it's really inconsistent across businesses. You mentioned it. If you put up a current renewable asset, it's likely that it's completely littered with sensors, which are 5 or 4G enabled already, and you've got a ready-made bed of pure and perfect data for that monitoring of that asset. If you look back at the asset, which was a commissioned process plant in 1984, the whole thing is driven by paper. It's drawings, it's documents, it's really difficult. So we've been pushing for many years for our customers to invest heavily in their digitalization strategy. So just stop saying that you're a digital company and start committing the money to actually create a digital platform on which AI can really give you advantage.
And I think Tarja said it earlier, which is, I mean, that's foundations, but you could try and solve everything, right? And we've seen it, right? Millions spent trying to get your data estate and up the whole estate. But to your point, focus on what you're trying to solve. What data do you need to bring together to solve that problem? And then you're not wasting time on something that's not going to generate an outcome. Henry, I don't know if you had a view on that?
Yeah, I was just going to say, I feel like the sort of silver bullet thinking can be really difficult with this sort of thing, right? Like, AI doesn't magically enable us to join up and solve problems of coordination at that level. In the same way, if you reframe that question to be, how do you get people to coordinate and unify at that sort of level and scale, you'd have the similar challenges. AI really excels, although it's getting more general over time, really excels at the narrow use cases. And echoing what you said about process, so there's a phrase I quite like of supervised process over outcomes. Don't see AI as a magical brain in the corner that can solve all the problems, but look at your process at a very granular level and automate the very small subtasks in a very narrow fashion, because those are where you get the exponential improvements, which are much easier to monitor, much easier to evaluate, much easier to find the limitations of the approach, which are often very subtle, nuanced, difficult to detect. The problems of scaling heterogeneous data sources, of coordinating at national levels, all of those sorts of things, I don't feel like we've solved them as a species, as for people yet. So we can't just sort of ask AI to do it and expect that to work either.
Yeah, I feel like arguably you kind of need to do both. So, at the grid level, there's a virtual energy network that's being designed, which is sort of a series of digital twins that talk to each other, and you have perfect control over everything. And the same, there's sort of, papers out there on how do you centralize these sort of flex markets to make sure that, you have wind in Scotland, but you have demand in London, and how do you even physically balance that? But like, could you have a central balancing market for the electricity markets? And I think it's nice as an ambition, but I think you kind of need to just eat, what's the saying? Eat the elephant at a time, or something. Don't eat the whole elephant, whatever it is. Meaning that you gotta start taking little bites out of it. You'll have a local electricity balancing market in southeast. You'll have a digital twin for this for this part of the grid, and you'll do this here and there, and companies are doing that. Startups are doing that. They're making money doing that. But the question then raises, well, whose responsibility is it even to have a kind of central view of the entire grid? Like, whose responsibility is it really to keep the lights on, and who's going to make money putting that in place? So I think it's the right ambition. I wonder, like, I feel like we shouldn't get distracted by it and just kind of do what you can. So I think the challenge is big enough that we just got to get started. I think that's been a theme throughout the days. Focus on action, bias for action.
So let's build on that then. I've got a card here that talks about the barriers of AI. We've talked about quite a few. I mean, data, foundational data, trying to solve too many things at once. But what are each of your views on what are the biggest barriers in front of us apart from ourselves?
I had, obviously, data was the big barrier for our customers. But the second big barrier is a bit more subtle, and it's actually the hype itself. The news media, what people read, what they perceive about the risks of AI, it's really clouding the judgment of industrial executive leaders to make good decisions. So, for example, a running plant will have 1 million sensors of information that will tell you pressures, flows, temperatures, wattage, and it's just streamed every second into dashboards that they see in their control rooms. Every single piece of data is a machine-created piece of data. There's no bias. There's no opinion in that data. There's no personal information in that data. So a lot of the noise around bias that's being introduced in Gen AI tools and other issues, which are hot media topics, are just simply irrelevant to some of the use cases that our customers are faced with. But it creates this really clouded judgment for our customers. So I'd add to data that misconceptions and, let's say, clickbait is one of the things that causes issues.
Yeah, and I think education and literacy as a whole, not just in terms of, we started by talking about what the applications of AI, but how does it really work, and how do you understand the risks in a way that isn't just hype but is tangible?
Yeah, I'd absolutely echo the sort of narratives we see in the media don't really bear much relation to the actual potential and limitations and potential harm.
But it's interesting that Hollywood actors are on strike because of fake. Yeah,
I think there are real genuine harms that we see in the world from the actual implementation of AI that is out there right now. I would caution you with bias there, because there's obviously issues of social bias, but data set bias does still occur in IoT techniques, and correlations with confounding variables have been something that we've had to really struggle with when I've been in the IoT world. So that narrative is very difficult, so that leads policymakers as well. And that lack of expertise and that lack of understanding, therefore, creates poor decision-making in terms of the policy actions that are around it. I think also that for me and for us in CPR, one of the big issues we have is that the copyright and intellectual property regimes are simply not fit for purpose with the machine learning world, I don't think. And navigating the thicket of international regulations, which are often quite contradictory, the different and the burdens that places, it's very inhibiting of innovation and of good usage of AI. So I think some sort of streamlined approach to data regulation, and with the new regulations coming in on AI, the EU, US, Japan, obviously the UK as well, hosting a summit in November, have all carved out positions that in various ways are contradictory to each other. And that's a genuine, real problem with adoption, and one that I don't know necessarily how we easily solve, except for having good international cooperation on this and collaboration. So getting expertise up into the upper echelons in the policy-making rooms, that sort of thing, extremely important. Having good international collaboration, streamlining the data, IP regimes that are around this. And then finally, I think as well, there's just not enough focus on, like say, the education piece, but that comes out as openness, transparency, explainability of these things. At the moment, how many of the AI startups that you read about, I don't know, probably don't subscribe to as many AI newsletters as I do, but ever publish anything about their self-evaluation of the efficacy of these things? And for me, that's a real red flag. And if you talk to someone and they say, what are your performance metrics here? How have you evaluated this? How have you checked that this is doing what you claimed? I would wager a good 75% of them can't do that. And part of that is means that a lot of the hype becomes self-fulfilling, because people see these things failing and not working, and that's also a real issue.
Yeah, we'll come on to Gen AI. We will get there, because that's what everyone wants to hear about. I think one of the real problems with that is the precedent that it's set. This idea that scale is more important, and knowledge of what data goes in is maybe not as important as it once was. And that's kind of, I think, filling the thing you were talking about, Henry. Tarja, do you want to cover some barriers? I can see a long list there on your side.
Well, I'm not sure I have much to add, actually, except I guess to counter those barriers or the kind of fear and the hype is not lose track of the profound impact that AI has had in pretty sensitive industries. Again, like energy, industrials. The pushback that I often hear is that it is very risk averse, and you've got sort of national critical infrastructure that you're dealing with, but it's adopted in healthcare, you know, cancer screening. There's, you know, identifying stuff we've done with the government on identifying harmful content on social media, detecting calls to prayer from terrorist recruitment videos. You know, it's not trivial that you're already able to do. So I feel like that gets lost, that it's not just apps, it's not just robots trying to kill us all. They're like really pretty boring and fundamental good things already happening. So yeah.
You don't have any more barriers there. The optimist of the panel is sat here. Yeah, I mean, I think that's an interesting point. And I think coming back to the education piece, a lot of the hype is focused on one part of AI. There's a ton of AI that came before, you know, like forecasting or kind of a more traditional based ML that just doesn't get looked at. Okay, we've got 5 minutes left. So let's just talk about the reg considerations. I mean, what within this sector, right? Let's come back to focusing on the sector. How can we still move even with those kind of uncertainties in the reg space? Is it really a barrier? Is it really a concern? Is it something that folks in the room should be worried about today? Or can we still move forwards, you know, whilst, you know, the dust settles or the refinement is done, shall I say?
I'd say let's be honest, we really welcome the active interest of regulators on AI, because if you wound back the clock only a couple of years, it was pretty absent. So I think that's a really welcome thing. They're taking it seriously and they're starting to build frameworks. So the work for the Centre for Data Ethics and Innovation has been fantastic to give us some robust frameworks for how, as businesses, we can make correct decisions. And I'd also make a call out to the Alan Turing Institute, who've done a great job of doing AI standards hubs for us. So as businesses, we can try to be part of the guidance or receive the guidance from that organization for the appropriate use of AI. I think we're at the start of a long debate, as you just said, about conflicting opinions on how to legislate for it. But the good news is people are paying attention now. So I do actually see a bright future with regulatory bodies actually helping to demystify some of the hype.
I agree, actually. A lot of the conversations I've had with other startups paints a false dichotomy between regulation and innovation, with a lot of people seeing innovation as stifled by regulation, but I think actually that's just absolutely not true and not the way to look at it. Absolutely. So yeah, but I do think as well, you know, we know, although there are open research problems around the harms of AI and how we solve issues around there, like, we don't need to wait for regulation. You can do responsible AI, you can do ethical AI, and that's something that we really try to champion. Like, so yeah, just do get stuck in. Like, the clock is ticking, and we need the benefits of applying this well are compounding. You know, it's a multiplier, and those geometric progressions. So have a good ethical and responsible approach to it that is mindful of its limitations, but at the same time you do that and you get stuck in, you get the benefits are, as you rightly champion, absolutely mind-blowing and transformative and hugely exciting. So I don't think we should see these as barriers. Like, they're things that, you know, they're conversations that are happening. This isn't a Facebook move fast and break things necessarily, but certainly you can apply it today responsibly and get those 10x, 100x improvements.
Yeah, I guess the only thing I would add from kind of regulation and safe AI perspective is kind of companies active in this space to take part in the conversation as well, and kind of be proactive in terms of, well, what are the solutions? Like, you know, adding protective models on top of Gen AI output so that you can't go on ChatGPT and learn how to make a chemical biological weapon or something, you know, and that exists, right? And to an extent, the train has left the station. So I don't think, like you said, it's not stopping progress, but I think tech as an industry has a responsibility to be part of the solution as well. And especially with the kind of frontier models and how fast it's moving and how nobody foresaw that and how no one really understands how it works, which is kind of scary. And I think that is the kind of, again, less so the more traditional AI, you know, that we understand pretty well, the narrow applications. You know, I would worry about that less, but the kind of fast-moving bits and making sure that, I mean, there's stuff that we're doing on a task force ahead of the AI summit on how bad actors are using frontier models like LLMs. And again, getting ahead of the curve, being in dialogue with, you know, regulators, with policymakers in the kind of conversation in the industry. And it's been, I mean, when last did you have the kind of the CEOs of the leading companies going to the U.S. Congress saying, regulate us, you know, make it easier for us to know what's coming? I feel like, I don't know. Again, I am an optimist, but I feel pretty good about, you know, I don't think anyone's taking it lightly that this has to be done in a responsible way, or there are consequences. Yeah.
My worry with the larger companies and doing the frontier models is that they're using the regulations to try and generate a competitive moat and advantage, because what we're seeing is the open source world is a source of huge innovation at the moment. And actually, I think most of the really impressive innovations and core research on actually understanding what do these things do, a lot of the core research on making these things more efficient, wherein a model with 7 billion parameters now can reach the performance of the first OpenAI GPT-3 model, which was 175 billion parameters. Those sorts of advances are all coming out of the open source world. And and I use that example intentionally because obviously one of the criticisms is frequently about the energy usage of AI. And actually the energy footprint of intelligence has gone down 3 orders of magnitude out of that advance on open source. And the sort of regulations that are being pushed by the larger organizations are quite restrictive of open source. And that's one thing I really worry about. And I think we need to be really careful about with the regulatory conversation.